So trig, or trigonometry is the whole name, is all about the study of right triangles. And we've already done a lot with right triangles, but there's a lot more. I mean, I took a whole class in college just on trigonometry. So we're just kind of starting with the very basics of it. But it's a way to find the sides and angles of a right triangle. And with trigonometry, we only need to know one side. So kind of like with the special triangles, we only had one side, and we were able to find the other two sides. But that was only if we had those two types of special triangles, right? So now with trig, we will be able to, for any triangle, any right triangle, if we're given one side of the triangle, we'll be able to find the other two sides. And if we have two sides of the triangle, we'll be able to find what the angle measurements are. So the two angles besides the right angle, we'll be able to find out what their angles are. Okay, so when you have a right triangle, first thing you're going to do is you're going to take your right triangle and you're going to label it. You're going to label it depending on what angle you're dealing with. Like here, see how they put that little, kind of looks like a zero with a line through it or something, but that's a theta. That's a Greek letter. So that's from the angle that we're dealing with. So we label it from that angle. So the angle that we're working with, we're going to label our right triangle opposite, hypotenuse, and adjacent. Now I think we've gotten pretty good at that already, because we've had to do that for some of the work we've done, right? Once you get it labeled, then there's 6 what we call trig ratios, where it's just basically a fraction that uses the designated sides of the right triangle. So here, sine of theta, we're going to use opposite over hypotenuse. So it's just whatever number is here is the opposite. Whatever number here goes in for the hypotenuse. Okay? It's just pulling the numbers off. Now sometimes one of those we're not going to know, and it'll be an x or something, right? And then, so this is sine. Maybe we should write those in. It's not sine, it's not sin, it's sine, S-I-N-E, that's the abbreviation. The COS is cosine and tangent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, look at these ones over here on the right side. Do you notice any pattern if you compare those to the ones over on the left? Compare the ratios over there on the right to the ratios there on the left. Not the names of them, but just like the opposite. What do you see? They're just flipped from the one next to it, right? So this one is sorry, I kind of messed that up. It's cosecant. This one is secant. And this one is cotangent. And what you should notice is that the cosecant is just the reciprocal of the sine, or the sine flipped over. The secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. So if we have, say, this triangle, so draw another right triangle up here. now I'm going to put that theta up in the kind of the upper left-hand corner of that triangle. Now, can you label that triangle according to that angle theta? Label it opposite, adjacent, and hypotenuse. So this side here, what would you say? Opposite, adjacent, or hypotenuse? So if we're going, it's like if we're going from this is the angle we're looking at, right? So it's across the triangle from it, so this is opposite. The hypotenuse is always the one across from the right angle. And then the adjacent one is the one that is like that angle is a part of it. And of course, we're probably going to flip them over, turn them around, upside down, you know. So that's the biggest thing there, is being able to label your triangles, opposite, adjacent, and hypotenuse. Once you do that, then we're just pulling the numbers off from the triangle. Okay, so flip it over to the back real quick. I just kind of made these numbers up. They don't really make a right triangle. But what if I said, what is the sine of theta? If we look back on the other side, it's opposite over hypotenuse. So if theta's here, which side is the opposite? What number? Would be the 5. And then the hypotenuse is the 8. And then the adjacent is the 6. And I normally just kind of go around and label them. O for opposite, H for hypotenuse, and A for adjacent. If we flip back into the book, the definition of sine is opposite over hypotenuse. So here, what is the opposite over hypotenuse? 5 over 8. That is how you find the sine of theta. Okay, what about if they ask us for the cosine? Now the cosine, we go back and look, what was it? Adjacent over hypotenuse. And what is that? 6 over 8. And tangent is what? Opposite over adjacent. I'm going to use a capital N. So let's see. Opposite is 5 and 6. Now, the cosine one, we probably should reduce it. Okay. Any questions there? Okay, let's flip back into the book. And let's look. This one, we're going to kind of jump around with our examples here because it doesn't go like quite in the order of how we're going to learn things. So look at example 2. And it says, find the sine of x. Well, the sine of x is this. Sine is opposite over hypotenuse, right? So which side is the opposite? The 5. Which is the hypotenuse? It's this one with nothing on it, right? And then the other one is our adjacent. So the sine of x is opposite over hypotenuse, so it's 5 over h. Well, they want us to actually figure out what that number is. And to do that, we're going to pull out old stuff. Okay? So if we know 2 sides of the triangle, how do we find the third side? Pythagorean theorem. So we're going to do 5 squared plus 9 squared equals, I'm just going to say h squared or c squared. Go ahead and do that. So it looks like it's the square root of 106. Now we can probably simplify that. We probably don't have room to show that work on there. But 106, let's see. Divided by 2 is 53. Oh, well, maybe not. Will anything go into 53? No. So we can't simplify it. I was wrong. So here we would say that the sine of x equals 5 over the square root of 106. Let's flip to the cosine page, cosine and tangent page. And look at example 4. So we're missing the value for the hypotenuse again. So let's go find that first. Let's find the value of the hypotenuse, because I know I'm going to need it. So it's 7 squared plus 3 squared equals h squared. Let's try this 58. simplify that one either. Okay, so that hypotenuse should be the square root of 58. So now it's asking us to find the cosine of x. So we've got to label this triangle opposite, hypotenuse, and adjacent. So which is the side opposite the x degrees? The 3. It's like on the other side of the triangle. Like if you start at that angle and kind of draw an arrow across the triangle, it's the side that you're running into. The one opposite the right angle is our hypotenuse, and then the one left over is the one that's adjacent, right? So, the cosine, what's the definition of cosine? Adjacent over hypotenuse. Adjacent over hypotenuse. So the cosine of x equals 7 over the square root of 58. There weren't any pairs, so we can't break it down. Okay, so 58 can't be simplified, so we just leave it at that. Okay, any questions? Seems okay? Okay, let's look at number 6. They're making us find the hypotenuse again. This time we have 9 squared plus 2 squared equals h squared. So go ahead and find out what h is. So let's see, 85. It can't be simplified either, right? Okay. So now that we have all 3 numbers around the triangle, what is the tangent of x? So we got to label this triangle opposite, adjacent, and hypotenuse. Go ahead and do that. So looking from the x, which side did you put as opposite? What's the number value? The 9. Good. The hypotenuse is that square root of 85, and then the adjacent is the 2. So what was the definition of tangent? Opposite over adjacent. So the tangent of x equals 9 over 2. Oh, we really didn't need to find the hypotenuse, did we? Oh well, we found it anyway. Okay, any questions?
So the like the meter making it just revolves around the right angle.
Where label it all depends on what angle it's asking you to look at the triangle in reference to. So like here, wherever the x is, or the theta, or whatever they're saying to find the tangent of, that's how you label it. So opposite from there. Okay, and then the hypotenuse goes in terms of the right angle. You thought what? If you look at the worksheet and look at all your right triangles, all of them have all three sides listed. Okay? So we don't have to use the Pythagorean theorem at all on this one. So the first thing I want you to do is I want you to go through and just label all 12 of these as opposite, adjacent, and hypotenuse. So just go through and label them. Opposite, adjacent, and hypotenuse. So here we're using this angle. So we're going to label it opposite. This is the hypotenuse. And that's the adjacent. So just go through and label them all. I'll give you a few minutes to do that, and then we'll correct them. See if you have them labeled correctly. First four, see if you have them labeled correct. O for opposite, H for hypotenuse, and A for adjacent. You good there? There's 5 through 8. Any questions on those ones? And then the last set. 9 through 12. Can we put phones away, please? Check those ones. Okay, so any questions on any of those? Okay, just let's see, we have it here. So let's look at number 10. So on number 10, it's asking for the secant of theta. So back to our definitions. What is the secant equal to? Which sides? Hypotenuse over adjacent. So if we look at these numbers, hypotenuse is 15, adjacent is 12. Let's reduce that fraction. Both of those are divisible by 3. So that's, whoops, you can't see that. So that's 5/4. Or, and we're going to divide this and turn it into a decimal. So 5 divided by 4, 1.25. So for this worksheet, I want you to give both the reduced fraction and the decimal. Are we okay? Okay. Any questions? No? Okay. Good. Get busy. You have a little over about 15 minutes left. You should have time to finish this, definitely.